All right, AP Physics, Unit 2, Dynamics, exam question number 3. I have a block here and a block here. They both have the same masses. And they're connected by a thin string, so it just doesn't matter, who cares. Block 1 sits on a rough surface, and it has a coefficient, a kinetic friction of 0.4, and Fs of 0.6. This has no friction. And I think it's important to write that down to help you out as the problem goes, and just think ahead. Real quick, again, I think it's useful to just do this. I have F of t, I have mass times gravity, but I have no friction. This one, I'm going to have my normal force, mass times gravity, F of t is this way, but this one will have friction. Those are the things that I know. So then we're going to go to the first questions on the diagram below, or just basically you have to draw it out. Draw a free body diagram for block 2. That's this one right here. So block 2, I had my force of tension, my normal force, my mass of gravity. There was no friction, so they will, if you add friction, they will take it out. So there's 3 points for A right there. Quick, easy, couple of 3 easy points. B, determine the angle. Determine the maximum angle of the incline can make without the block sliding down. So they want to know this angle right here. If I keep moving it down like this and make it steeper and steeper, there's going to be more pulling on it. At what point does that actually move? So I need the math. They want to know, determine the angle. It's the math. So let's do that. And I'm going to do block 2 first. And I know I have to break this tension down into my X and Y axis. And I'm going to say that going down is positive. So I've got to subtract my tension. I'm going to count just the portion, and that's going this way, so that's positive. And it's at rest. We want to know what an angle it is that we can use that maximum friction of u sub s, and that's what's being on the horizontal one right there. So if I just rewrite this quick, I'm to here, I'm that far. I don't know this angle, that's what I'm looking for, but I have some information I can get from block 1. Here's the one with my static friction, and it's at rest. So I'm going to do the sum of my forces for both of these ones. Why do I need that? Because when I do the sum of the forces in the x direction, I've got F of t minus the static, no acceleration. So F of t is just equal to F of s, which we know is u sub s times the normal force. Well, I need the normal force. Only place I can get that is back over here. F of n minus the amount of gravity. Again, no movement, so F of n is that. F of s is this. So the tension on block 1 is just the friction force times, which makes sense, how much texture there is, times the amount of force that's pushing down on that object. And then on the one on the frictionless surface, it's just how much mass is going down. Texture doesn't matter. That should make sense to me. I'm going to set my 2 tensions equal to each other. And look at my masses cancel out. And the sign is really equal. All of a sudden, gravity is gone. Mass is gone. All that really matters is that angle, and the angle is dependent upon the texture. And that turns out to be 37 degrees. On C, when that maximum angle is exceeded, the blocks will move. So I've now gone from use of S to use of K. Does the tension in the spring increase, decrease, or move determined the same? So they want to know, is F of T going to go up or down or same once they start moving? Well, the only way I can do that is let's look at the math. Let's compare those values together. And when I'm going to do this, block 2, remember we did it up here. And really the only difference here is we said it's at rest, so I got rid of acceleration. When I have movement, I'm not going to get rid of that. This time it stays in. So the tension force is going to be equal to the amount that's pulling it down, and you take away some mass in the acceleration. Block 1, we're going to have the same situation. We're not going to be able to get rid of acceleration. We did up there, but here we can't. So it's going to decrease. The tension is going to decrease because when it's at rest, when we had zero motion, we just had the portion of the mass pulling down at the sign. But when it's moving, we now have the acceleration mass going there, and we can see that that value is going to be less because I'm subtracting that.